Yikes. Hey, it's me, JP. It's time for another episode of John Park's Workshop. And Lars is over there in the chat. Yay! What's going on? If you're wondering where the chat is, that's where it is. Go to our Discord, which is adafruit.it/discord, and head over to the live broadcast chat channel. Also, hello everyone over in YouTube. Hey, FX Music and FL or FI and Dave Odessa, welcome. Thanks for joining in. What else have we got going on? What's new? Let's talk about our jobs board. We have a jobs board over at jobs.adafruit.com, and if you head on over there, you can see such open positions as this right here, pretty near me. This is a company called Light Gear, which is in Burbank, California, Southern California. And they are looking for an engineering laboratory technician to do things like test new lighting controls or light emitting products, assemble lighting prototypes, assist with development of test protocols, build, maintain, troubleshoot, and repair electrical instruments or testing equipment, and on and on and on. Really cool. I just clicked on their link there, and look, they do stuff like this, big, huge lighting solutions. I'm guessing for entertainment, but could be for anything. They've got some serious looking gear there. Neato. So yeah, that's just one of the many things you'll see over there at jobs.adafruit.com. So head on over there and see if there's a job for you. That's jobs.adafruit.com. All right, what else have we got going on? Hey, did you know that I have a show on Tuesdays? I do. It is called JP's Product Pick of the Week. That's the logo right there. And every week I take a new product and put it through its paces, show you how to use it, some examples, some coding. And this week it was this cool resistive touch controller, the TSC 2007, which I like to think is one of the most clear names ever on a chip. It's Touch Screen Controller, TSC 2007. I hope it was made in 2007, but I'm not sure about that part. But anyway, the product of the week is usually on 50% discount, and you can get up to 10 of them. So if you have big plans, you can score big during the show. There's no need for a coupon code or anything like that. You just put it in your cart, and you get it for that reduced price. And I like to do a little 1-minute recap, and this is that. It is the TSC 2007. It is a resistive touchscreen controller. I have the TSC 2007. It is plugged into a Feather RP2040 that has a OLED and a couple other things connected here, a little Neo key. And here is my screen plugged in. So if you look at my screen there with the little bongo cat, you can see I've got the X number in the upper left corner and the Y number in the upper right corner of that display. If you look at that number down at the bottom there, that will increase and decrease as I push just a little harder on the screen. TSC 2007 touch screen controller for resistive touch screens with I2C over Stemma QT. Hey, how about I bring the microphone back on? Yes. All right, so next up, I'd love to go over a cool little tip in the CircuitPython parsec. So get ready for it. Here it comes. All right, let me get set up here and show you my little tip and trick. So, first of all, I decided to put that little DVI out thingy to good use and have a bunch of Larses spinning there that say CircuitPython in the middle. That's just to entertain myself. Is that too distracting? I hope not. Let's leave it up. Okay. For the CircuitPython parsec today, I wanted to show you how you can use the tile grid sprite sheets in order to advance through frames of an animation or move an image around the screen. So you can see here I have a little sort of stylized version of a cassette tape or a reel-to-reel tape, and every time I press one of the buttons here, we get an advancement of these little reels going forward. If I tap the other button, they go backwards. And the way I'm doing that is actually I have a single image that has 3 frames of the animation on it, and each time I press a button, we're just moving this BMP to a different section of the grid. Now these can be big, huge sprite sheets like you find in an old video game, or in this case, just 3 frames. The way we do this in CircuitPython is I am importing the Adafruit image load, that's one of the key things here, and then when I bring in this bitmap, I'm bringing in this bitmap with the palette, Adafruit image load that BMP, it's called realsheet.bmp, and then I set up a tile grid. So tile grid is display.io tile grid, the bitmap that we've picked before. I set the width to be 3, since I have 3 images on this single BMP, the height to be 1, so I can only scan sort of horizontally through an image, and then I set the width dimension, so it's 128 pixels for the little window that we want to look into. The full image is 384, and then the height is 64. And then in my code, every time I press or one of the buttons or the other, I'm just incrementing that value from 0, 1, 2, and that's just picking a sort of map on that sprite sheet. And so you can see as I hit forward, I'm kind of going right through the sheet, and if I go left, I'm going left through the sheet. And so that is how you can use a sprite sheet with tile grid inside of CircuitPython. And that is your CircuitPython parsec. All right, well, I hope you enjoyed that. And this is partly in preparation for a project that we're going to be working on today, which is going to involve a sort of digital tape loop. And so I wanted to start working on some little graphics for that. It is the sort of next project after the Walk Mellotron, which is using a real cassette player to be able to control the tape speed in order to play it like a Mellotron. This is on a similar vein, which is going to be looping individual tape loops and sort of mixing them together using CircuitPython Audio Mixer. So we'll get to that in a second, but before I jump into that, I wanted to check in on the chat and see what's going on. Okay, we got a great GIF animation from our resident GIF animation master, Yanisku, which is some sort of automated tape dispenser looking thing, I think. I don't know what that is. Looks like a CG infinite looping machine kind of thing there. That's what I'm suspecting. Duct tape that just rolls itself forever and ever. I like that. By the way, I brought out that, I didn't really explain what that gizmo is. I can unplug it from here. I showed this before. This is this really neat, what is it called? The Dazzler from Game Bueno Dazzler, I think. It is the feather variant on it. So this is a big HDMI serving chip. I said DVI before, it's actually HDMI serving chip that handles a lot of the difficult stuff. It's basically a graphic card for your feather board or other board. I've shown this before, and boy, I can't remember much about, yeah, I think it's Game Bueno Dazzler. And we had these, I think they're out of stock right now. Uses the Spartan 6 chip. But that's what I have running on there, and it's good for doing really fast transforms of transparent images, which is what I was doing there. It also has a couple of inputs for nunchuck accessories, Wii nunchuck accessories, and it has an SD card on it, so I could probably do a lot more with it than I'm doing. All right, so I wanted to talk about some digital tape loop stuff. We have been doing cassette things, but if I jump over to the workbench here, I'm actually going to move that little sample player. You'll recognize that. I'm going to move that out of the way here for a second, and I'll show you something on the Fates board here. So let me give that some power and get that up and running. Add a little camera there. So this gizmo here, I've shown it before. I can't remember how much I've explained about it, but this is essentially a clone of the Monome Norns. And the Monome Norns is a little Raspberry Pi based sound computer. It allows you to run scripts to do all kinds of things with sound. It can process sounds as well as create synthesized sounds using Super Collider and Lua scripts to tell Super Collider what to do, and much more. But it has a really good DAC paired with some nice interface stuff. It's a beautiful OLED screen, and this one uses a Raspberry Pi 3 or 4. The real Norns uses a compute module. And, oh, I just realized I've got the wrong little upper screen. There we go. That's better. So one of the many scripts that you can get on this, if you go into the interface here, you can scroll around and select different scripts that I have loaded on here. It's all open source stuff. And one of the ones on here that I really like is called Reels. And the idea behind Reels is that it is a 4-track cassette loop. How do I pick you? There we go. Nope. Are you running already? I think it's already running. Run, Reels. Reels is unhappy with me. Why did I break the demo? Hello? That should be going back. I'm going to reboot you. Acting naughty. Good demo. So the idea behind this is that there are 4 loops that you can load a audio file, wave file into, or record into. So this has inputs, so you can record an instrument into it. And then you can manipulate those real tracks, everything from equalization and flutter and adding some little effects to the speed of the playback of the whole reel. So it's as if you have a 4-track cassette, and you can slow down and speed up the 4 tracks together. You can also do some individual sample rate things. So I thought this was pretty inspiring and wanted to see if we could do a sort of related, inspired by thing with a CircuitPython microcontroller instead of this more advanced device. All right, so let's see. Let's see if I can make you launch. There we go, he launches. Okay, so sorry the screen is doing a little bit of a funny thing with my shutter speed up here. I don't know if this will change if I adjust. No, I don't think that's going to fix it. So what you'll see here is if I load up some reels on here, let's see, I might, yeah, if I load a reel, it's a set of samples that I already put into here. Let's play it. And I'll turn on a little speaker here. So you can see I'm just able to adjust the speed of those 4 tracks that are playing together right now and add effects and fun things like that. Also, I noticed there's some funny wagon wheeling happening with the display, so it looks like those are traveling in the wrong direction sometimes. Let's go ahead and hit stop on that. So not only was I inspired by the idea of having some looping audio playing back and possibly manipulating their sample playback rates or other parameters of them, but also just love the visualization. So especially this, you can see, get that little tape head coming in there and pressing against the reel of tape, and the reel's going in the proper direction. Really cool. This, in fact, was inspired by another device, which I don't have, but I'll show you a little image of it. And this is the OP1 from Teenage Engineering, and let me grab a browser real quick. Right, Engineering OP1. So the OP1, you will see often it is, there it is on Amazon. They're not cheap. Let's see if I can get a big image of it there. So you can see there is the, that was sort of the inspiration that the more, the lower resolution OLED on the Norns and the Fates is based on. This is a really high resolution screen that they have on the OP1, and the new version that just came out has an even higher resolution screen. But this notion of having 4 tracks to record into is sort of the fundamental thing of working with that particular device. So it's a synthesizer and sequencer, but it allows you to lay down a track, let's say a bass line, lay down a set of drums, a lead, and so on, and then you can even bounce multiple tracks down to a single track. So it's this artificial limitation. It's a digital device. Of course, you don't have to do it that way, but it's meant to be a creative inspiration to have these limitations of it. So that right there, that loop led to the one you see here in Reels. There it is on an actual Norns rather than the Fates one that I have. And by the way, Monome also makes a shield for a Raspberry Pi board that is slightly simplified as far as UI. I think it has fewer knobs and buttons, but otherwise it runs the same software. And so that's an alternative, because this one's a really expensive, beautifully made, solid chunk of billet aluminum milled out. The shield is much cheaper, so it's a little more approachable and meant to be more approachable for like educational settings and so on. But a lot of artists like to use them as well. So those were the inspirations there, and then what I decided to do, actually, let me stay here for a second. What I decided to do was take another look at the breakbeat breadboard. So you may remember this project. This is something I did that was based on some cool demos that Toddbot had put up on social media, and it is essentially looping a set of wave files that stay in sync with each other, and then the buttons in this case are just used to adjust the gain. So do we hear them or not? Now the demos, maybe I'll play this, we might be able to hear it. So you can see the idea behind this was to set a bunch of synced slices from a breakbeat drum loop so that you can kind of go in there and remix it and play the pieces that you want. But they're always going to stay in sync with each other because they all start playing at the top of the sketch, and then all we're manipulating is gain. So this project I'm doing now is just a slight variation on that, where the idea is, instead of having a bunch of different drum parts that can sync together, what if we treat it a little more like a mellotron, which you'll remember from the Walk Mellotron project, and have essentially one tape loop that has been recorded at different pitches, and then each of these buttons can play them back. So it's a sample player that is playing back samples that are in a scale of some kind. Could be a chromatic scale, could be pick a mode. And I would like to make it a little bit more of a drone type of experience. So something I might work on today that I haven't done yet is have the buttons just be a toggle that'll set the state of the gain, so that we hear that note or that chord playing, and then we can add to it and subtract from it to make more ambient drone kinds of things. So that's kind of my goal, and I'm actually not sure how the tape loop graphic fits into it yet, because I don't think we can do variable speed, but it's something maybe we can find some sneaky ways around by adjusting sample rate so that it seems like we're adjusting speed. So I knew I wanted to get the tape loop into there, because, I mean, come on, look at that thing. It's just so cute. So add a little OLED with a tape loop, and it's going to make it all that much better. But let me show you a little demo of this thing in action that has now had the audio samples replaced with some tape loop style drones. So I'm going to power this off properly this time. Sleep. I love this. It says when the not red light stops blinking, disconnect from power. So there's a LED on there that might not always be green, I guess. So it said when the one that isn't red. Whoa. Okay, you can hear I have a bunch of sort of echo reverb on there. So yeah, just leave that on. Plug this in. Okay, so what's happening now in code is, uh-oh, why does that camera not want to switch? Oh, I have a camera in the way, sorry. Let me go get that out of there. So what happens is at the top of code, there are 8 samples that can play together. Those have all started and they're just running. So you can envision 8 wave files that are just playing basically seamlessly over and over again. So if I hold down one, you're going to hear just that note play. It's actually a chord, so I did again this sort of chord tritone-ish thing. So I recorded roughly 8 seconds, so you'll hear that looping. Or you probably won't even hear it loop because it's fairly constant. I just have a little noise in there and some flutter on pitch of a couple of the tones. And then you can hear I'm providing some echo from the black box here, some reverb. Right, so there you can hear when I hold down 2 of them, we get some nice interaction between the tones, some little harmonics and beating things because they're a little slightly detuned from perfect based on some modulation that I have of the pitch on the original recordings. Super satisfying. I really enjoy that. You can just kind of zone out and play that and mix that together. It's a lot of fun. You can almost, especially with all that reverb, you can't really play a bad note. They all sort of fit together and work together. So let's take a look at what that code looks like, how that works, and then if we have time, I'll also show you a little bit about how I set up the to create those sounds, because generating those sounds in the first place is part of the fun. One way that I thought of doing it, but I didn't actually have the time, was to just hook up my Walk Mellotron that we've been working on and my keyboard and just play and record that directly into here, because it's a similar type of sound, and I get about a little more than an octave there that I can play with, so we could record some nice samples from that. That would be great, and that may be what I ultimately do. But for expediency, I generated these with a virtual modular synthesizer. So let's head back over here and we'll take a look at the code. I'm going to need this. So let me turn that off so it doesn't make a bunch of sounds. All right. Also, let's go like this, and how about like this? Yeah, so that's going to be in there somehow, a screen. Maybe not that exactular one, but I like exact one. But I like the idea of an OLED in there. One of the things that I want to do with this is just a simple hardware thing, but since I said these are probably going to be like a latch or a toggle, I'm planning to build this with those little lighted buttons that I asked Lady Ada if she could carry, and she found them. Let me see if I can find a an image of them. They essentially are the type of buttons that you find on a Roland 808 drum machine and a bunch of other synthesizers. Let's see, what did we call these? Well, let me just look up 808 buttons. That's kind of a way to find them. So I'll bring up a Chrome capture. So it's these types. They have a little step in them and there's a nice close-up. An LED, so we'll see when one is latched. They are momentary buttons, but by pressing it in software will latch that on and light up the button. So you can see which ones are playing, which I think would be kind of nice. And these are great for sequencers. I'm not doing anything that advanced or ambitious with it, but just to be able to use those buttons I think will be really nice aesthetically. So that was part of the inspiration here. And now let's take a look at, uh-oh. My mic pack causing problems? Is it having a problem with, let me try screwing in the, I wonder if I've got a flaky wiring on this again. Tell me how that sounds. I'll just speak for a moment and see if you can get that. Sort of, it buzzes every now and again. That sounds like a faulty wire. This could be in need of some reinforcement. When I was playing with the Fates, it was buzzing. I wonder if I was grounding to something. Is it okay now that I'm standing here? I hope so. There we go. Let me get that out of the way. It's fine now. All right. Mysterious. Okay. So the code for this, let me go ahead and open that up. I'm going to plug this in. Don't save that. Static bursts once in a while. All right, I'll try to stand very still. So I've plugged in that KB2040 there, and I'm opening up the code on it. There you go. So, is that the right one? Nope. I have two of these plugged in. Let me unplug one of them. Don't save. Open. Cancel that. Did I plug it into a... Yeah, I plugged it into a cable that's not actually connected to my computer, so that would explain that. Hey, there it is. There's lights and everything. That's quite helpful. Okay. Let's try this again. There we go. So what I'm doing on here, it's the same as the breakbeat breadboard from before. Same code, just changed out the waves for now, and then we'll see if we can make these latching or not. So the wave files that I'm bringing in, you can see here, the key stuff is that I've got audio core and audio mixer. And since this is a RP2040 based board, I'm using PWMIO instead of the analog output. But it works very nicely as well. I'd also forgotten about this until I was trying to put files on it. There's some, probably, I haven't updated the version of CircuitPython on the board in a little while, and I think some of these things have been fixed, but on the version that I was running, one of the earlier 7.1 or something, we sometimes would have little glitches with the USB systems and audio conflicting with each other, making it difficult to drag files onto it without first going to the REPL and stopping the program running. So that was a whole little dance that I had forgotten about, but that's partly why this 3-second sleep is here. It's to try to let that USB audio stuff settle before we start working with the program. But here you can see I've got these 8 files on here. I've just named them tape 0, 1, 2, 3, 4, 5, 6, 7. And I'm setting their mixer volumes at 0.4. I should probably test this out with all of them playing and see how that gain sounds. I can't remember if this thing just limits it to one or if it can clip, but we want to potentially adjust those based on how many are playing so that we maintain a consistent volume, sort of like a compressor. So since we know which ones are actually being played, we could mess around with gain level when we have 5 of them versus 1 of them playing. The setup here is the pins that I'm using for these buttons, individual GPIO buttons there. Let's see, Todd says he thinks audio mixer auto gains for you. That makes sense because this didn't sound like it was jumping around in volume. Thank you. Then I have some keyboard setup using keypad. There's the audio out is on PWM on D10. And then we set up the mixer. So right now in the mixer, you can see, let me make this a little more legible. There we go. We have the voice count, which is however many voices are in that list. So I've got 8 voices. So count the length of WAV files. Sample rate right now is set to 22050. That's what I have my WAV file set at. You could probably go lower if you needed to. Right now, just looking at this earlier, it seems like the mixer object is where you set your sample rate. So Scott mentioned something about this last night, Scott Shawcroft. There may be a way to change these on an individual voice basis, which would be great because that's what would kind of give us a speed control on individual sound files, which would be pretty neat, especially if we added a knob so you could do little warbly detunings and stuff. Channel count is just mono, so I'm just going out one side, one pin. 16 bits per sample. We set up the mixer playing, so that just runs all those WAV files that have been opened. Or rather, it starts the mixer. Now we open up all these individual WAV files. And here's this function called handle mixer number pressed. And this is what currently just changes the level from 0 to whatever the original was. So in this case, it's this 0.4. And I have that just based on a press right now. Now we have in the main loop, we check all the keypads. This is using the keypad library. And then when one of these is pressed, we set the mixer to the opposite state. So that's what flips it. So off and on when pressed or released. So let me set up a little, I won't use the blue box this time. I'll just put it straight into the little speaker here. It will not sound anywhere as cool because reverb makes everything a lot cooler. But let's see, maybe my mic will freak out too now that I'm touching these grounded audio things again. Let's see. Let me know if it's terrible and I'll cut the audio demo. So let me turn that up a little bit. By the way, I didn't just play them straight through. This is the 8 that I recorded. Okay. So let's see. If I wanted to change these to be a state change, let's see. What would I do? If the event key number is pressed, right now I'm setting this to true. I guess I could set it to whatever opposite of what it is, right? What's a good way to do that? Can I ask them what they are? Let's see. How about I'll make a state called mix state equals false. And let's set that to not mix state, and then mix state equals not mix state. Will that work? I don't think I need this. All right. Oh, sorry, it's going to make glitchy noises. And let me bring up the REPL so it can tell me what I'm doing to anger it. Let's see. I've just got a typo. Yeah, okay, so now this acts like a toggle. Question over in YouTube is what, thank you, Andy. Andy said I missed the underscore. The question on YouTube is what microcontroller unit is that? This is the KB2040, the keyboard. So this is a Pro Micro sized and pinout board that we made originally for using in mechanical keyboard projects, but I just happened to use it for this one. It's nice, it's got USB-C, it's got a bunch of GPIO, it has a little STEMMA QT connector, and it's an RP2040, so kind of a neat choice for this. You can see why having the lights is going to matter, because I don't know which ones are lit. And you can see my code has problems, so I'm having to kind of double click everything to flip that state enough times. So ignore that like actual code there, but it's just the idea of setting these up so that they have a little toggle without needing a mechanical toggle switch, which I think is nicer, less prone to failures, just using a little momentary switch. So let's now, I think we can dive a little bit into the generation of those tones, just because I think this is kind of interesting. Unfortunately, I didn't save the file that I used somewhere that I can get it right now, I don't think. Yeah, so we'll recreate it, but that's okay. So I'm going to open up VCVRack, which is what I used for this, and let's create a little screen capture of that, if you'll bear with me. Dexter, totally. If only those LED, if we had buttons with LEDs, that would be perfect. All right, so let's grab the rack window. And I'll scale that down a bit. The setup this is at right now is what I used originally to record a sine tone, just a single root pitch tritone to the tape. I can plug that actually into so that's what I recorded originally to my cassette to do the Walk Mellotron stuff. And what I'm doing really, I didn't end up using any sequencing on that. So really all that matters is I have these 3 sine wave generators, and I've used a quantizer to pitch those to 3 tones that I wanted, and output that through a little mixer and recorded it digitally. So that's really similar to this, and then I guess I can work from this, and then the main adjustment I made is to add a little way to change the sort of root note of the chord together. So what did I use for that? Midi to CV and for simplicity, I just used my computer keyboard as a MIDI controller. And let's see. That, sure. Okay, I can go through this little mixer, I think. So I have 3 little mixers there that I can change that route with. Let's turn the volume up a little. So that's the basic idea. I just have my computer keyboard acting as a MIDI keyboard to send it notes. Another actually nice way to do this is with this little 12 key. So here's a module that just looks like a keyboard. And that's actually what I used. So I'm going to simplify this for a second and just have one of the tones playing. So let's give that an output from here. I'm going to bunch some things up together so I don't have to keep scrolling around quite so much. Okay, so that's the input to these. So I just hit record. Moved up to the next one, picked whatever my 8 notes are going to be that way. But in this case, I'm just showing it feeding into 1 sine wave, and I just fed it into 3 that were tuned into the intervals that I wanted. And then I added a little bit of modulation, some very slight random modulation because I actually used a different sine module that had a FM frequency modulation on top of the bass note, so that just allowed it to warble a little bit, and then also mixed in some noise. So you can see I'm a big fan of VCV Rack because you can kind of patch together the thing that you want. You can kind of automate things, so it's possible to send a message to the little recording module to start recording when you press a button and stop recording when you release or some other event happens through some gating. So you can even set up a sequencer and it'll just do it for you, and every 8 seconds it'll move to the next one if you want. So a lot of fun sort of logic programming that you can do by patching together modules, not just for creating sound, but for sort of building the little program that you want to happen. So that's how I got the 8 sounds in there. If we look back at the code here, you can see we've got these 8 waves right here. And since I recorded those accidentally as stereo and 44K, and I wanted to get them down to mono and 22K sample rate, I started going into, I use Adobe Audition as a wave editor similar to Audacity, which is free. But that's a pain when you're doing it 8 times. And then I remembered ToddBot has a tip and trick about using a command line program called Socks to do similar stuff. And you could even put a shell around that and batch it up and do a whole bunch of conversions of audio files. So that's what I did after the first one. I said this is for the birds, doing it in a GUI, and then I went over to Socks in the command line. So if Todd's around, he can probably throw that tip up there. I had a little note I had made of it, but he actually has it up on his tips and tricks GitHub, which is great. So thanks, Todd, for that. So let's see, questions. Let me know if you've got questions. I'll check out the chat. And also any suggestions or ideas on this, the tape loop thing, how I'm going to integrate that. Any thoughts, let me know. That would be cool. Let's see. I think Someone said they were thinking of building one. Dexter says, now I got to build one of these looper devices. It's a lot of fun. Of course, it doesn't have to be just pitched sine wave things like this. You can do all kinds of different loops, but those sound particularly nice at running at the different speeds on the different notes, I think. Let's see. What else? Questions or thoughts? FX Music finds toggle switches very satisfying. Oh yeah, you know what? I when I was digging around back here, this is where I happen to have put. This is another option. I built this little toggle board. What has 8? Yeah, it says 8. So I could make this the interface. This is going into a little cutie pie here. I can't remember what I was doing with this other than the LEDs and switches. But this is kind of overkill because we get LEDs and the toggle position, but fun anyway. So that might be a way for me to test this out as well. But I think I'm going to use those little 808 style buttons. Let me know if you have a better name for those. I can never remember. Let's see. Yeah, question here. FX Music says this tape loop into Clouds could be nice. Clouds is a module from Mutable Instruments that is great for making beautiful soundscapey, granular, reverby things. Absolutely. Rich asks, is CircuitPython the right language for an audio app? Subjective, I know. And Todd said he would use Arduino. I think you were answering that question. It is much more efficient for audio stuff. So yeah, so like synthesis, I don't think you'd want to try to do synthesis and effects in CircuitPython. The Teensy audio library is great for that kind of stuff. Also Mosey are a couple of audio libraries for Arduino that make audio, high quality audio, much more attainable. But this kind of wave playback is great in the audio mixer inside of CircuitPython. So it depends on what you're trying to do. I have a project. I've done a couple with a Trellis M4 that used the audio library from Teensy because we ported that to the M4. It's the only one we've ported it to. So either you're going to use that on Teensy 3 or 4 or an M4 based chip if you're going to use the Teensy audio library, but it's great. A lot of DIY synths, really nice DIY synths are made using the Teensy audio library. And thanks, Todd. He put up his link for the preparing audio files using socks. Excellent. And I think that's it. All right. Well, thanks everyone for stopping by. Thanks for your participation in the chat, and also for letting me know when my microphone was going crazy. Sorry about that. I just finished, by the way. Let me jump over to the back to the Learn guides here. If you check out, this is the latest Learn guide. So this is the one I was working on a couple weeks back. It is good to go now, and it's working better than I had hoped. In fact, the interactive MIDI exchange of LED information with the GUI is working perfectly now. I'm not sure why. At one point, it was taking double clicks once you adjusted things over on the computer. Now it works flawlessly, and that's great. It may have just been a simplification of my patch that I was using in VCV Rack, but now we get. I'll turn audio off on this, but now you'll see in this video as I press the buttons on the Neo Trellis, we get the trigger sequencer lighting up over there in VCV Rack, and then in a second here, I'll go and use my mouse. Right now I'm using the mouse to adjust all those LEDs, and they are in sync just like that on the Trellis, and no funny business with double clicking. So yay for that. So go check that out. Also, I was just chatting with FX Music over in our chat about making a version of this that runs on the Trellis M4, the Neo Trellis M4, which is the integrated one with the 8x4 pads. And so he's taken a crack at it. It looks good. There's just some questions about mapping, so I might put a follow-up one in there. Also, I just tested yesterday the new Neo Trellis library that is in PR from C. Grover that adds a brightness adjustment. You couldn't do that with multi-trellis before for various reasons, so or not easily. So now we'll be able to set like fully saturated, fully bright colors, which is easier. Just say red is going to be FF0000, and then tune the brightness using this new library. So thank you so much, C. Grover, for that. Once that is merged into the main branch there, I will update the code to use that. All right. Well, thanks, everyone. That's going to be it. I will be working on the Walk Mellotron project and get a guide out for that, and then be diving more into this digital looper. We'll see more about that probably next week. For Adafruit Industry, I'm John Park. This has been John Park's Workshop. Bye-bye.